A very good afternoon, respected Chairman Sir, members, CGM, NHI staff, and all those who are present out here. Um, I'm happy to be part of this event of capability building and would be sharing my presentation in just a few seconds now. Allow me to share the screen, please. Hope my screen is visible. Right.
Yes,
So
it is
here,
visible.
yeah, thanks so much. Yeah, like I said, I am Biju Balakrishnan and representing GR Infra. I'm based out of the GR corporate office and been entrusted the role of leading health safety environment and the portfolio of ESG. Here we are discussing on the safety management and highway construction as well as the operation and maintenance during the operation and maintenance phase. Since I understand we are the latter half of the first half and I have my limitations on the timing, I have kept it to an extent that we could really have an understanding of what safety management is all about. And then progressively during the next sessions or the next events, we could have a detailed discussion. But trust me, at the end of the session, you would be enlightened in what safety management or safety practices is all about during construction and operation maintenance. So to start with, I would say I've sliced the entire event into three parts. Just a brief of what safety management is all about. Then we dive into the operation and maintenance, the core operation and maintenance part, which uh, you know involves a lot of manpower in it, and we are putting the workmen and the road user at risk, the core area of that. Similarly on the construction one, so I wouldn't be covering the entire of O&M or construction, just the core area where life matters, right? And feel free, if at all you have any concerns, either you put it on your chat box or at the end of the session, we could have a discussion. I do have a small case study at the end of it. So we could have around about 2 minutes on that, please. To start off on the safety management system for um, most of the companies, I would say, most of the companies, when I mean say that it is more aligned with the ISO standards of 45001, what it really means is we've got 4 pillars. And the 4 pillars are safety policy and objectives. This institute, this organization or corporate should have a policy and objective where it clearly states their safety thought process. Then you have the safety risk management. Now, safety risk management, we all understand, similar to a business risk management. Safety of the people, of the workmen, of the road user, they're all focused on this. We've got the safety assurance part where you monitor, measure, you conduct audits, and you analyze data for the betterment of a work activity. At the end of it, you have a promotional activity like the one that NHI conducts at the start of the year. You do have an event on road safety and multiple other events that goes along the year. So all 4 are the pillars for safety management system. And this, in fact, drives the organization towards excellence. Now, this management system is then later broken down by all organizations into a kind of a framework. Now, what this framework looks like for safety is you've got your customers, you've got your client, you've got your stakeholders, and you've got the legal system. So both of this together needs to have a planning at all levels. It could be on a project site level, it could be on a corporate level, it could be on on different levels. You got to have that understanding of what is your stakeholder or your legal requirement talking about. You plan it accordingly. After the initial planning, you come into how can you implement and operate it. Now, to implement and operate safety practices, first and foremost is identifying the risk of that activity, understanding the activity. Then you specify duties, your roles, responsibilities, and then you get into a lot of documenting systems which also include your work permit, your training documentation, your TBT, and also including your emergency response plan. Okay. Now, with this implementation operation comes a lot of checks and balances where we definitely will have areas for improvement. Now, these checks and balances are recorded, documented, so that time and again we go into the analyzing phase and then rework towards planning. Now, this is a kind of a cycle that the management of that particular company understands, reviews it, and calls in for further actions. In general, what we say is it is a PDCA cycle. I would say a plan, do, check, act cycle. Now, to get this entire thing right, we need to first and foremost understand that safety is an integral part of every business. Okay, be it on a client side, be it on a concessionaire side, be it on a advisory side. So every part, safety is an integral part. Now, when we make that an integral part, that is when we drive in a safety culture. Safety culture does not happen in a day, it takes time. And why does it take time? Because this list out here, from tracking legal requirements to understanding ISO standards, to understanding what the client or relative stakeholders, what do they desire? What is the process that they have set? Being a role model in that process. And then you encourage people to be more transparent. When you have workers, when you have your contractors, when you have your concessionaires reporting with observations, with near miss, this is when you build in transparency and give them the confidence that things are working out right. You set out KPIs, you set out KRAs, so on and so forth, until you have an entire system that is running around the PDCA cycle, like I mentioned earlier, so that a culture starts building. Now, with this, we also should understand the first and foremost part of setting up a culture is understanding the activity in hand. Now, the activity here, an activity would definitely be a construction activity or an O&M activity. Now, construction activity, get the method, the process from the design, from the planning to the execution, get it clear across the entire team. For example, I would just take one example of, say, girder erection, which is quite critical at most of the sites. So just taking this as an example of how a critical activity is broken down so that everybody has enough of clarity. Now, in a girder erection, during a girder erection, the worst of the worst thing as a safety guy, I got to consider what could go wrong. And what could go wrong? My crane or whatever machine is involved, it fails. Now, this is the ultimate thing that could go wrong. Now, how do I really prevent this? Or what are the real causes of it? I got to understand. Just to prevent, I need to understand that aspect of it. So I've broken it down into a cause and a preventive measure. We'll look into the mitigating measures and consequences later, but let's understand this. This is just an example, please. All other activities are broken down in this similar fashion, right? So here for a girder erection thing, we do have the machine involved, that's a crane. We do have the load involved. And lastly, we've got the weather and the safety control measures. Now, crane, as we all understand, comes with its own requirement. You need to inspect the crane, got to have a third party inspection. The ground needs to be done well. It has to take cater to the load. And at the end, you have a dry run or a mock drill. Having done this, ensuring that your crane is in good hands also, we set in to make a lifting plan based on whatever load is it, what shape, size, weight. We identify the load and then create a lifting plan. Now, having done that, you got to understand what kind of a rigging practice gets involved. What you would have constraints with your load carrying capacity, you would have constraints with the area. So understanding all that and the shape of your load, what kind of a CG does it maintain? Now you got to understand that rigging process. And of course, for that, you need competent people to support you. From the crane operator side, each and every step, he's got to understand the safe working load capacity of the crane, whether it is within the parameters. To help him, he would definitely have a signal man if at all he is in a blind spot. And of course, the weather, like today, the entire weather needs to be considered. Most of the places it is raining. So how do you really understand it better? And at the end, having understood this entire process, we have the safety control system, starting off with your permit to work system, checking whether any loose objects are left out, checking whether each and every personnel on board is trained, and the roles and responsibilities are clearly identified, the fall protection system is in place, and finally the entire of documentation, starting from the lift plan, from the third party certificate to ensuring competency training, all this has to be maintained by the safety team on ground. And having said this, with all the preventive measures in place, this is the method in which you could prevent a failure. Now, we've done, I would say 99.9% of our task is ready to go. For girder erections, we are feeling safe and let's go. But there are times when, you know, it does go the other way. And for that also, the safety team on ground needs to be prepared. If at all, after all my considerations, there is something that I couldn't even envisage, I couldn't even think, then I need a mitigative measure. So it has happened. Now, how do I control it? First and foremost, I secure the area. Go into the experts. It could be the client, it could be your advisors. Go into the experts, check with them what needs to be done next. Get the emergency response system in place so that if at all you need to evacuate, considering the golden hour period, get that in place. You isolate live equipments in and around the area. There could be live lines, there could be utilities, okay, there could be traffic. So move that out. And then control whatever damage could happen, control it to a large extent. So this is an example of a girder erection and activity. Okay, this is one of the most common activities. This activity, how does a safety team, along with the execution operation team, how do we work it out to keep it safe? So I just wanted to give you that risk assessment or risk management process. Now, having said that, risk involves a fair level of understanding all across. It involves a lot of partners. It is just not safety team that could drive safety all along. You need experts. And who is the best experts? It's definitely the engineer on ground. And the engineer has to understand each and every activity, the work method, and the risk assessment. Now, on the terms that are being used, you could just understand it better. RA stands for risk assessment. SWM stands for safe work method. So having understood both of these methods, the engineer then goes in to identify the control measures. Now, these control measures generally are listed down in the form of a checklist. So it helps the engineer day in, day out to check these are the minimum requirements. Having understood that control measures are in place, what does the engineer do? He simply calls in the safety team to verify it. Now you have somebody, a doer and a verifier. You split the entire activity into a doer and a verifier. Okay. Now having verified it, now the safety team takes a call whether it is within the guidelines, within the SWM, within the risk assessment. If it is within the risk assessment, no issues. If it is not, he calls in for a reassessment. He does not let the job go ahead. He calls in for a reassessment. If everything is in place, he says yes to it, and then you start the job. So this is the initial process for all activities. And then Having said this, now your activity could last in for an entire day, or it could be a month-long activity. Now you got to monitor it. The simple monitoring mechanism is check on the work permit system. A work permit system is called every day. Now check on the work permit system, whether it is abiding by whatever the checklist is talking about. And if yes, continue with the job. If no, then again, you go back to the engineer to rectify it. So this is a normal work execution process that is undertaken jointly by the safety and the execution team together on site. Now, having done all this, it does not really indicate like my monitoring, my implementation process are in place, does not really indicate that we are safe enough. So long time back, round about the 1930s, there was a, a professor by the name Henrik and Mr. Bird. Henrik and Bird, they came up with a triangle popularly known as the Hendrik's triangle theory. Now, this triangle theory tells us that at the base of the triangle, you have unsafe acts that gradually builds on over the period into a fatality. And what the unsafe act, the amount of unsafe act, if you realize, it is for 3 lakh unsafe acts. That's a huge number. 3 lakh unsafe acts. You would end up with having 600 near miss cases. 600 near miss cases would eventually develop into 30 injury points. This 30 would finally go into 10 lost time injuries, and 10 lost time injuries would have 1 fatality. So this is what Hendrik and Bird wanted to tell the entire world in the 1930s. Now, what as an organization, how do you look at it? We look at it in the reverse order. Okay, we look at it, if I have to have 1 fatality, that means I need to have observations to the extent of 3 lakh. I need to have incidents around 600 near miss cases. Now, how do I prevent that? We look at it the other way around. And from there, we build up a process. This is nothing to do with GR Infra. This is just for everybody's understanding that I have picked up the figures. So this is how we have understood Hendrik or Bird's triangle. We set them into 2 different aspects. One is on something as a lead indicator, and the other is called the lag indicator. Now, I need to prove Henry's triangle is non-existent in my organization. So what do? I build on the lead indicator. My lead indicators are two toolbox talks, or the short of a TBT. I build on training, raise awareness. I pick up hazards, observations, and the controls. And I also support near miss cases. This 4 of it, I keep telling all the people on ground, this is where I need to emphasize on. Having done that, that is the only way I can stop the lag indicators, or that is the only way I will stop myself getting into the Hendrix triangle. This is where every site, every project safety or an engineer on ground is emphasized or told how important your toolbox talks at the start of the day is. It is the base of not achieving an injury, where every project manager supports a TBT, where every project manager supports a training, every client, every concessionaire does it. This is the reason, because it is the foundation to stop any incident happening. Right? Near miss cases is definitely proactive, because the more the near miss cases that you have, more the chances of analyzing or stopping or preventing an injury on chances, more the chances. Hence, it has been put into a lead indicator and not looked into as a lag indicator. So the more the near miss case you have, the more chances of analyzing and having correct SOPs, right? Now this is what I say, calls in as a PDCA cycle, where the entire team works together to drive in safety. Now, getting into what with our core issues, I would start off with operation and maintenance, because most of the things that are there is also part of your construction phase at some point of time or the other. Okay, at a different stage. Now, every asset on the O&M phase, every asset needs to be understood through the asset management plan. Now, what does an asset management plan talk about? It is just about aligning policies, and these policies would definitely call in for bigger umbrella termed as a strategic asset management plan, or SAMP. Now, this SAMP, it rolls out into different projects or different assets, where every asset needs to understand the issues, the external and internal issues. Okay, who their intended people are or intended parties are. Now, based on that, every project works out an asset management plan in which they rope in daily activities, they monitor their objectives and targets are being set, and how good are they at improving it. And the entire process would go into performance monitoring by different clients, even by road users. Now, first and foremost, every asset needs to have this asset management plan in place. Having done that, let us understand what are the risks as far as safety is concerned. Now, when you have an asset management plan, you got to understand what are the risks. Like every business risk, we got to have safety risk also in play. Now, for an O&M phase, the risks that are really prevailing as of today, or I would say quite essential, is on the familiarization of new workers. Every asset gets a new workers every day, day in, day out. Now they got to be familiarized. They are going to be exposed to live traffic. So they got to understand things differently. Live road, it's a big critical issue. They are going to handle electricity, utilities under the ground, overhead also sometimes. They're going to handle asphalt, it's hot mix. They're going to handle driver concerns. You will have toll operations, and toll operations by itself is a high risk activity. And at the end, you've got your firefighting, your rescue systems in place, the RPVs, the ambulances, the cranes. I just got a message that, are you seeing my thing clear? I hope it's fine now. Yeah. Yeah.
Yes, sir.
Yeah. Thanks for letting me know that. Right. How do you familiarize? Very simple. The new workers that come on board, you simply get them to the office, get them on board, get them into the cycle of screening, induction, issue them IDs, maintain their data from the next of kin to the village that they come from, what was their background, provide them the required training, issue them the correct PPs. Now, when a villager comes on board, it is not necessary that he understands signages. Give them an opportunity to understand what signages are. It could be temporary, it could be permanent. Does it really mean? How does it matter to them? So get that as an awareness building measure. Make them understand of good practices. Some of the good practices that I could capture, I did display it as photograph. Now, these are projects that really make a difference as far as safety for road user and the worker is concerned. The first one you can understand is a buffer zone where a worker is limited within the inner line. He does not travel into that 1.2 area. You've got machines on board as of now. You've got convoy vehicle. You've got the traffic management vehicle that are there on the highways helping place those cones. You've got truck mounted attenuators that are there on the O&M phase. If at all you have a two-lane a lane, a main carriageway converted into two-way traffic. You've got systematic processes aligned. And the last, the worker who is there on ground needs to be supervised. We got to understand the worker requirement time in and again during the course of the activity. So it could be, as simple as, water availability, first aid, or attending his bio requirements. So a supervisor is the guy who would understand it better. On the toll plaza front, as far as NHI is concerned, we've gone a long way, but there are toll plazas that are of the old model, and it has to be understood that the toll operator, he needs to be protected in all ways. And the best way to protect is keeping the potential contact zone away from him as far as possible. Now, how do you keep it? Generally, you have those concrete barriers lined up all along. I've also seen people using, restriction, width restriction measures, wherein you simply keep a goalpost kind of an arrangement where vehicles only of those size will enter, and they avoid risk of hitting the toll booths. So these are excellent practices that are still available on site. We've got live remarking on vehicles where a highway maintenance vehicle is clearly indicated to the road user that there are chances that this particular vehicle might slow down for some purposes, and these vehicles generally ply on the slow lane unless it is an emergency vehicle, as an ambulance would be. So this kind of indicator marking is very helpful to the road user. Now coming into our core area, where how do we ensure that the road user and the worker are in an environment that is safe for both? And as an asset, we have traffic running smoothly. For that, IRC SP 55 clearly outlines the guidelines. It clearly gives you all the parameters that are required to ensure this is in place. Now, our understanding of IRC on ground over a period of time, everybody has represented it in their own easy way. But I would like to deliver what the IRC really tells, or what the table 4.1 really addresses, or the pictures in 10.1, what does it really say? Now, giving a few examples, and it would be easier for us to understand any other work zone. Now, work zone, if at all, on a live highway, we have to occupy the slow lane. Now, to occupy the slow lane, on a road user perspective, I have to keep the road user informed if the highway is between 80 to 100 speed limit. I have to keep him informed at least 1 kilometer away or 1100 meters away. I got to start indicating my signages. From the man at work to getting his speed down to 60, and then progressively moving to 30, 30, 30, and then touching upon the initial taper zone. My taper zone, if you look at this figure, it starts from A1 and goes down to B1. The distance between A1 to B1, as indicated by IRC, table 4.1, for a speed limit of between 80 to 100, it is advised to keep it at 85 meters. The entire length of your taper is 85 meters. From there, I move into a buffer zone, that is B1 and C1. Now B1 and C1 is, I hope my screen is good enough because I do have a fluctuation happening.
No, your screen is visible.
It's visible, right? Because on
Yes.
my end, I have a fluctuation happening. Let me just connect the charger, please. Give me a moment. Yeah, I've got repeated chat comments coming in. Please share the PPT. Definitely, I'll share it. I won't keep it up with me. Yeah, thanks for that. Yeah, so B1 to C1 is the area that's called the buffer zone, and you got to maintain it at 100. And after the buffer zone is the area where generally your work zone would be happening. And like I indicated earlier in the photograph, the work zone and the outer end will have a buffer space of 1.2 meters. Now this 1.2 meters is just to help the worker not to get into the external area where your, this is where I'm talking about. We don't want the worker coming here because here you have the traffic moving around. We don't want the worker coming here, or my vehicle, if at all it infringes into this area, he still has room to move out of it. So we're giving the opportunity to both of them and then helping the work to get completed in time. Now, in between this work zone, to be much more safer, there are companies that are deploying the first hit vehicle or an attenuator, right? And after this, we move into the exit buffer and the exit taper zone. So all in all, we have from the approach taper to the exit taper, you have the lengths clearly defined in the IRC. And this is just not randomly, it is proven, it is scientific. And this is where road users are benefited and the workmen are benefited. Yes, definitely there would be some inconvenience as far as traffic is concerned, but nonetheless, it does help in clearing off the issues that are there. That it could be potholes, it could be a structures, whatever it is. We could, navigate out of it very fast. Fine. So moving into the next, this is more to do with the entire carriageway getting diverted into a different lane from RHS to LHS or LHS to RHS. Now, how do we do it? This is again on a similar front. When we block the carriageway, we have to block the first of the lanes. That is, you block the slow lane. And after blocking the slow lane, you keep a distance before the vehicle, so that you allow the vehicle on the slow lane to merge with the one that is on the fast lane. Give that room, and then create a taper. Now this taper is again aligned with your table 4.1, where it is based on the speed of the road. If it is somewhere varying between 60 to 100, you automatically will have the ratio. We keep it on a safer side as 85 meters. You align the entire thing and move the traffic into the median opening. Now a median opening, based on the volume of traffic, size of traffic, it is derived somewhere between 15 to 25 meters. This is the minimum that you would need. 15 is the minimum that you would need. Move them into the median opening and get them across into the two-way road. Now, when getting them into the two-way road, we have to understand that on whichever carriageway that your traffic is, those road users are not accustomed to having head-on traffic. They have been traveling kilometers and they are used to one-way traffic. Now you have to give them an opportunity to understand that there is some obstruction in front and you could find oncoming traffic. So this is where the importance of all the signages are. This again indicates you got to keep them informed at least a kilometer away, which progressively indicates their restriction to speed. How do they understand that work is in progress and two-way traffic coming up? So all these signages have to be in place and then get them into that work area. So we got to understand this mindset of the road user. Now, having said this, there are times where between two median openings, you have a distance of say around about 2 kilometers. And in this 2 kilometers, I've seen that there is no division at all. The concessionaire or the contractor, he thinks he anyway sees an oncoming traffic, so why would he go into the next lane? But trust me, that is not how road users would think. road user, since I said he's been driving a one-way traffic, and all of a sudden you have pushed him into it. So at the back of the mind, though he has seen these signages, when he travels around about 500 meters and sees that there is no traffic coming in, there are high chances he will move into that other lane. Why? It is because he's been programmed earlier. The kilometers that he had spent earlier leads him into that behavior. He moves into that lane where you don't want him to be. And that is where you have incidents of oncoming traffic collision. So this partition is of very essential thing as far as the behavior of this road user is concerned. Right. And then, Chairman, sir, you were talking about your experience on the road. I think typically it is this kind of a requirement where the contractor or the concessionaire, he understands how to display it to the road user and without creating too much of a disturbance. So the entire work has to be barricaded, where we consider the incoming and outgoing traffic of the work activity itself. So these are jersey barriers that have to be aligned next to each other. Now it depends on the longevity of work. If it is a one-day work, definitely we would have the uh, portable barriers or the water-filled barriers. But if it is going to go in for a long period of time, when I say long, it is more than anything that is more than 3 days, extending beyond 3 days, it is best advised to have concrete crash barriers supported with, the externals are supported with water-filled barriers, so that if at all there is an impact, you still have the water-filled barriers supporting the road user. Right. Now, all these work zone layouts are designed for keeping in mind 81 to 100 kilometers an hour. And the specifications of signages, I have put a table out here. This is IRC SP 55 2014. It's 10.16. Yes, you could, the members out here, the participants out here, you could have a different figure as far as a taper zone is concerned, or an exit taper. You could have a different figure because the table itself gives you a ratio of 1 is between 1 is to 20 to 1 is. So those ratios are multiples. So you as a provider or as a facilitator, you've got to be on a safer side of thing and giving that that number. Like I said, 85 meters of taper. Right. Yeah, some might contend that instead of 85, why couldn't we give it to 100? Well, it is your choice. 85 is at least the minimum. You consider that as a minimum. Right. So this is as far as work zone layouts are concerned. And how is it supported? It is supported by an entire system which gives the opportunity to the road user to identify what are the signages, what are the things that will support him in case of an emergency. You would have the RPVs, you would have the cranes, you would have the ambulances, you would have the flagman on board, and of course the solar blinkers that are there. So as far as O&M is concerned, this is what I had planned to show it across. I would like to pause here. I do understand a lot of chat messages have been flowing down, which I would take an opportunity to address soon after this session. Apart from that, anybody wants to have a minute to discuss, I would be happy. Or we could take it at the end of the session.
Balakrishnan, will you please share your email ID and mobile number in your chat box so that they can come back to you through mail.
Sure. Sure,
But
sure,
this
sure.
session is closer to the discussion.
Absolutely.
Yes.
Right. Right. So let's move on to the construction safety part. Here too, I have pictured those events that are critical or those areas that are high on the injury rate, and we need to understand it a bit differently. So the first on the list is definitely excavation. Every structure or everything starts with an excavation. And when we start with excavations, things that we got to identify are your utilities that are there underground and overhead, the kind of soil that you are handling with. So these are two areas that we'll have to look into. And the hazards that are listed are, it could lead to soil collapse, You could find an utility that could lead to an explosion. You could have hazardous atmosphere underground depending on the trench that you're creating. So if your trench is too deep enough, you definitely would have an hazardous atmosphere. Are there adjacent structures next to you? Have you defined the access and egress? Are people or vehicle moving around the excavation? It is almost always seen that the moment you excavate, there will be 10 onlookers. It could be villagers, it could be roadside users, but there would be a, so you got to handle that. Moving machinery around over the excavation. Now this could be your work machinery, also the road users. So how far are you pushing the machinery from your excavation? During the movement of your machinery, people could get entrapped into it because there are blind spots for the operator. It could lead to drowning, especially in this kind of a weather where it is raining in most part of the country. And then, of course, the reptiles. Now, how do you control it? Well-defined measures that are already there are engineering practices, sloping, benching, shoring. So these three things are well defined, and based on the type of soil, type A, B, and C, we definitely would have sloping and benching. And if it is beyond that, we definitely would consider shoring or sheet piling, whatever the engineering term is. But before we do any of this, the first and foremost part of our understanding should be what kind of a soil are we handling? What is the moisture content in the soil? What is the height or the depth that is you're going down? What is the width of the entire area that you're covering? Do you have any other kind of a load that is acting? Right, it could be a structure that is nearby, it could be the traffic. So this has to be considered before you undertake any of this engineering practices. Having done that, there are other control measures also, or checking your utilities and the atmosphere that is down below. Like we all know, there are utilities that are not mapped. Uh, it could be an electrical line, it could be the networking line. So those are seldom mapped, and we will have to use methods uh, like the recently introduced down penetrating GPR. They help, but at times GPR also do not give you the right method, do not give you the right indication. So if at all there is a doubt by through local sources, if at all there is, it is best to go in for a manual excavation and then follow it up with a mechanized one. And like I said before, hazardous atmosphere, where we check for the type of gases that are there. And also we got to check through the LEL meters if what is the explosive limits, LEL or the UL. Check it out, what are the limits that are there. Oxygen level definitely needs to be understood. So that was as far as excavation was concerned, the control measures that we just had. Work at height happens to be the number one killer as far as construction is concerned. Any kind of construction, be it in infrastructure, be it on the building space, office space, work at height is always the number one. And having understood the type of work that we're going to undertake, with the photographs that are shown, these are typical cases. Any work at height, when we travel across, be it, it's not restricted to villages or cities. Even you go to the best of the airports, you definitely would find work at height issues where somebody is on top without basic requirements of a ladder or a work platform, or not having PPs. So these are the general areas of concerns. One thing that I would like to really highlight in this is the recent usage of mechanized lift or MEWPs. Now MEWPs facilitate easy movement. They take you to different heights. They call the mobile elevated work platforms for a reason. But when we don't use them well, or we don't secure ourselves in that confined box, there are high chances that if at all there is an event, we would fall off the box. So, we got to understand an MEWP is an engineering device which comes with its own risk. And if you do not understand risk well or move around with without a safety harness into that box, you are endangering your own life. So this is some one thing that we all have to keep in mind, because we keep inspecting different bridges at different times. On the metro side, we've had recent cases of fall of material, which is being aired by the media time and again, where a poor road user who's got nothing to do with my work, but when he's coming back from his work or moving somewhere with his family, he gets hit and he pays the price. So these are major concerns that we've got to understand. And how do we tackle these major concerns? First and foremost, for any work at height, you got to access that place. Now, accessing the place, there are only two ways. Either you have a ladder, proper ladder, a stair tower, or whatever MEWP mechanized lifts that you have. Now, these ladders, they come in with standard arrangements. It's only when I go into makeshift arrangements that I will have an issue. When I say makeshift arrangement, if my ladder is, I have to access a height beyond 9 meters and I still use a ladder permissible limit is 9 meters. And if I have to access the next part of it, I want to go into a 10th meter or the 11th meter. What I do is I use that same structure on which the ladder is and I try climbing it. And that is where I fall down. My ladder has supported 9 meters. Waki, though, the other 2 meters are my own method. So this is where it will cause hurt. Similarly, on a stair tower, if it is on in a standard manner, it is defined to cater to a load. But when I do a makeshift kind of a thing, or I do not inspect the previously used stair tower, it ends up in an issue. MEWPs, like I just mentioned, MEWPs are machines that need to be inspected by third-party members, third-party inspectors. And having inspected, it's got to be monitored if people are using it in the right manner. So this is as far as access is concerned on a height work. After accessing whatever levels, we got to have a work platform. A work platform is clearly defined that you got to have a fully boarded work platform so that you move in an easy manner. You don't have the fear of falling over. You have mid rails, you've got top rails. Mid rails are something that is almost above your knee height. You have a railing that is almost above your knee height. And you have a top rail that is almost round about your waist area. So it is 600 mm and 1200 mm measurement. So, but to the worker, when we explain it to the worker, this is how we tend doing it, keeping it above the knee level and the waist level. Fully boarded working platforms ensures two things. One is giving confidence to the worker that he is well protected. It also gives confidence to the worker who is working down below or moving down below that there is no item that is going to be falling from top. This is again generally seen where structures are concerned, where bridges are there, be it on a metro, be it on our bridges, where we have these open zones. And these open zones, generally we put in a jali kind of a thing, a rebar tied together. It sometimes works, sometimes it does not cater to the load. And the time that it does not cater to the load, that is when somebody gets injured. The best practice is keep it barricaded. Now, to what extent it depends on the time limit that you have. Is it for a day or is it on a month end? If it is on a month end, the photograph that is indicated, this really applies, where you are clearly having a mesh, a toe block, you're having guardrails, mid rails in place. This is a very clear indication that there is an opening, and be aware of it. The next line of defense, if at all there is some kind of a material that falls from height, or your worker, your staff falls from height, we need to give them still a room to survive from injury, and that's a safety net. Now, safety net comes in very different shapes and sizes. The only thing that we've got to understand is we've got to keep your safety net tied not more than 6 meters below the point of work. So the falling material hazard, it provides a kind of a cushion between the net and the ground below. So if you keep it too low, there are chances that whatever falls from there, it might go and hit the ground. So, right. So this is the understanding as far as the safety net is concerned. The most critical part of every construction is having a lot of your work done by machines. Deploying machines is definitely, going to, help you reduce the manpower that is there on site. It reduces the time frame and executes well all the projects. Now, having said this, the man-machine interface is of the highest risk for any project. Now, when I say man-machine interface, it is when you have a worker standing or a staff standing around any equipment. Like in this picture, I've shown an excavator. An excavator does have a swing radius. Now, anybody who is within that swing radius is prone to get hit unless he understands things differently. Right. So a man-machine interface is everything that concerns between the machine and the men that are around it. Getting caught in between that in that area leads to an injury. And we've got to be aware. It could be a excavator, it could be a forklift, it could be a crane. All of these machines, they come with their own risk. And to identify the risk and having control measures is what we need to understand. First and foremost is we give a very clear audio visual cue to the fellow worker or the road users that this is a machine that is placed here for certain activity. Before the start of that machine itself, we sound the audio devices. It could be a delay start mechanism, it could be your flashing lights. You have to have an indicator that this machine is going to start, because there are incidents where the operator and his fellow worker, they sleep under these machines, and when you get a sudden call from somebody and the operator moves the machine, the poor guy who's sleeping behind gets crushed. So we need to have that kind of an audio visual device on board these machines. We've got to give enough room for pedestrians or the workers to either take shelter inappropriate, they don't go under these machines to sleep or rest, or they walk in well-defined areas that are, you know, uh, you have laid a boundary so that vehicles do not infringe that. You set defined speed limits. There are speed limits from 5, 10, 15 for every work site, so that your driver is clear that you can expect anybody crossing in that area. Drivers are an asset to any industry, any concessionaire, any contractor. These drivers need to be trained. They got to be understood differently. The drivers, they come from different backgrounds. They have been doing their job for a number of years. They've got into a kind of a behavior pattern. Now, we got to understand that behavior and then have a course correction. The best way is getting him down through a defensive driving training. And let's not forget, every member on site is best to have your high visibility jackets or a retro reflective jacket. Whenever you're on site, it has to be worn so that you give an opportunity to the driver and yourself of not getting injured. Whenever machines are in operation, the most important guy that an engineer or a staff or a worker should look forward to is a banksman. Banksmen are termed differently in different organization. Banksmen, signalmen, traffic marshal. These are all the terms that are there in our industry. Their jobs are more or less similar. Now, a signalman or a flagman, his first and foremost job is keeping the machinery away from himself or any other person who is in and around that area. Now, to do this, he has to understand the science behind, keeping himself visible to the operator. Right, he has to maintain a visual contact with the operator wherever, whether he is standing in front or at the rear. He has to have that kind of a visual. Right, so his job on as a banksman is very important as far as activities like grading, activities like asphalt laying. These are activities where the banksman, a real competent banksman, would do a world of good to the road user and the occupier of a project. Now, having talked about the O&M phase, the construction phase, now all these activities, they need a kind of maker checker kind of a concept. Now, this maker checker kind of a concept is best understood as a work permit system. It is applicable in all kind of industries, be it manufacturing industry, be it a construction industry, it is applicable. And it is called in as a legal document also in many of our acts. Now, what is this work permit system? It basically tells you that what and all are the activity, the prevailing activity, what are its control measures? Has those control measures been considered? Like we started off with, a girder, and I did show you the preventive actions. Now, those preventive actions, they need to be listed out in your work permit system. It is a kind of a checkbox where you are understanding whether these actions have been done for the day or not. Now, this gets recorded by the site management supervisor, operator, whoever is carrying out the work. It is a simple kind of a permission to whoever wants to carry out the work. The contractor team, the concessionaire team, the contractor or that workforce, he takes in the work permit, gets it across to the issuer, and then sets out an entire process of verification. This work permit document is simply catering to the hazards. Have they been identified, and are the control measures there in place? It is just an assurance part of it, where day in, day out, our engineers, our safety team keep approving the work permit and at the same time verifying it. Now, work permit, when is it really required? It is generally required in activities that are not common. It's not on an everyday basis. Activities like blasting, excavation, height work, confined space, hot work permit, electrical work, radiation work. These are a common list of uh, areas where work permit is generally called for. There are other areas also. It depends from client, depends from the consultant or the other stakeholders. They do call in night work permits, they do call in general work permits also. So it depends from place to place. And how is it really done? I'll quickly take it across. First and foremost is your performer or the guy who is doing the activity. He calls in for a work permit 24 hours before the activity is done, or when the RFI is called. The moment he submits the work permit, the performer, he also understands whether the preparation for the work is up to the mark. Having done that, he submits it to the issuer. Now, the issuer is generally your engineer on site. Your engineer comes on board, he checks whether that performer has the necessary safety precautions in place to get the job done. And based on that, he issues the work permit. Now, when the work permit is issued, that is when the verifier comes in, and verifier is generally your safety guy on board. It could be your client, it could be your consultant also, but you have to have a verifier who says that the work permit is respected in all ways. And after that, the performer commences his work activity. Now he carries on his work activity, and when the work activity is over, finished, the issuer closes the work permit, and then it is filed. Now this is a standard way to ensure that your risk control measures are being respected in all forms at the ground level. And it is a very well documented manner so that at any point of time we could have it for further analysis. Like I said, at the end of the session, I would be going in through a case study. Now, this is uh, something that most of the time when we travel across the national highways or state highways, we often see some worker or the other on the live road, and most of the times we also think that, you know, to complete that entire given task on the live highway, it is a real risk. So I came across a female worker who was hit by an HMV while she was carrying out, cleaning works of the pothole. Just a glimpse of what it looked like. Like, this was the arrangement that was there at that location, where you had people engaged for pothole works. There was fair amount of, I would say, warning signs and cones. But when I say fair enough, it was not fair enough as far as the road user was concerned. Okay. Your IRC defines it in a certain manner because it has been studied thoroughly. When I take a different call, there are high chances that would lead to failure. And this is one such sort of an event that happened where the worker, if you see, got hit here. She was sitting beside a cone and clearing a pothole. Now, a road user, if I look at the road user perspective, he is driving HMV. For him to notice a lady worker sitting beside a cone, okay, almost of the same height. When you said you are almost at a 1 meter height from the ground. Okay, the chance that the road user must have seen the lady is fairly less. And why did the truck move or HMV move into that work zone? It was simple. There were other vehicles moving alongside. It's just a 3.5 meter width area where an HMV needs to negotiate both on the right and the left. So when he was disturbed on the left of his vehicle, he automatically moved into the right, and in between that, this lady was caught. Right. Now, as a case study, when we took it up, we needed to understand at a very different perspective. Now, the perspective is this, and these are the general, I would say, the right way in which a safety member or a safety engineer needs to understand an incident or understand how do I get in control measures. These are the different levels. You try to either eliminate it first, eliminate the very reason of deploying the worker, or you go into substitution or isolation. If that's not possible, you get into engineering controls, followed by administrative controls and your PP discipline. So this is the way in which every control needs to be ascertained for any activity. Now, in this particular case, it is simple of isolating that entire work area. I isolate traffic by creating my own workspace as in relevance to the IRC. So I create a very good work zone. After creating it, now since I've isolated it, Then I get in my engineering controls. My engineering controls are very well established in the IRC. It tells me that my outer area needs to have a buffer space of 1.2 meters. Now, if that 1.2 meter was here, then that lady wouldn't get crushed. Use of mechanized method, instead of deploying a lady down there, if you could get a compressor just to clean that spot. And if that pothole was just a small thing, we could go in for a cold mix where you just lay it and then move out. So these are engineering controls that could be looked into. And then, of course, with the engineering controls in place, you get your administrative controls also. Your administrative controls is perfect supervision, where supervisor is aware where his workman is and how dangerous it is or how risky is it. How he takes a call on whether should I deploy a flagman, where do I position the flagman. This is where a supervision comes in. We create a work zone that is as listed as in the IRSP 55 and have a work permit process. We could also have a first aid or a shadow vehicle in place and then build awareness among the team members. So these are things that can be looked into for every deployment of a worker in the work zone. So this is a small case study that I had. At GR Infra, for us, now, since we are into this domain, our workers, our staff, they are of high importance. We've come up with this logo, which clearly states material, human, asset, and reputation. These are our prime value. And our aim is always achieving zero as far as safety is concerned. Zero in incidents, zero in injury, zero in fatality. This is our aim. To drive the aim, that is where I shared the entire PDCA cycle or my framework. And keeping our workers motivated, these are a few examples that I would say. Keep them motivated, learned, have the knowledge on board, give them good rest shelters, and as a backup plan, have the ambulances on board. Now, as a company, every company are at different stages of their safety performances. I would just throw in a bit of light where we could picture every organization that is linked with NHAI. You could place them in whichever zones you would understand. The first and foremost zone that a company would be, a new budding company would be on a pathological, where the company or the organization does not care much as long as he does not get caught. Or if somebody is caught, the best way to get rid of it is get rid of that employee. So that's on a pathological thing. And then you have a company that's on a reactive part where safety is considered important. We do have a lot of accidents. And following the accidents, we do have a lot of discussions. And after the discussions, for a time period, it is high on agenda. And after that, we lose interest. So some companies are in the reactive stage. We've got a calculative stage where we do manage our systems well. Lots and lots of audits in place. We've got advisors on board who support our systems. So this juncture is calculative. From the calculative, we move into companies that are proactive, where safety is driven from the top, where our leaders are aligned with the safety management, where safety is integral part of the business. And we need to fix things before an accident. This is where the understanding is, where you have procedures, we have practices in place. We've got a very clear understanding of how an activity has to be done. So that's where companies would be in a proactive stage. And then finally, you would have the generative thing where safety is a chronic unease. Today, when we are discussing, it has to be in every one of us that there is a worker on site as of now who's got a chance of getting injured. And that is the reason for my unease. There is a sense of urgency. If there is a safety concern, I have to do it now. Why? Because my target is zero. Safety is never considered as a profit center as far as, putting your money into resources. When you put your money into resources, your budget into resources, it is for the benefit of getting your job done in the safest possible manner, and that is your profit center. You are minimizing delays. And from the ground level, from your worker level to your contractor level to your supervisors, we need to embrace them so that they share the best of the ideas. Get them into discussions, get them into the conference rooms, get them into your boardrooms and talk to them. We got to have those events. You could have open house meetings, you could have conclaves, you could have various other events where we move from the offices down to the ground level and check with them. And those companies are the ones that are high on the order and generative. Now it is up to us. We understand where we are positioned and take steps to progress further. And this is about being increasingly informed and at the same time sharing your trust and accountability with all. And every member on this, we got to understand that it is my responsibility to ensure I am safe, my family is safe, and at the same time, the workers on board are safe. Right? So I think for the questions that you've shared on the chat box, definitely I would get back to you. I would be definitely sharing my mail ID and mobile number to the listeners who are here. If you could note it down, I am available on 95606 33116. I repeat it again, 95606 33116. So this is my mobile number. I would definitely be sharing my email ID to you all.
Thank you, Balakrishnan.